Today we are going to go over 9.5 part 1 polar areas. The formula to calculate the area bounded by any polar curve r equals f of theta between alpha and beta is given by 1/2 integration alpha to beta r squared d theta. So let's have a look at the picture. So given any polar curve r of theta. So how do we calculate the area? So first, we are going to draw a ray from the origin. As we rotate the ray counterclockwise, first it will touch the start point of this curve. This is our angle alpha. And then as this ray goes, follow the curve, it will go to the end points. So this is our beta. So the area covered by both two rays and r theta, this gives us the area calculated by the formula. So first, you have to decide the start and end points. And then you are going to connect those points to the origin, 0, 0, to find alpha and beta, where you start, where you end. Let's have a look at the example 1. So given this function, you can plot this using your graphing calculator. After you plot it, it will look like this. And then you can press trace. It will give you theta equals 0, x equals 2, y equals 0. And then you hold the right arrow, you can see it going this direction. So theta equals 0, start from here. So as this goes, we want to see when it will come back to the same point to cover the whole region. You see, this is our ray. As the ray goes, it starts to end points, the ray will cover the whole region. That's the area we are looking for. So we can see theta equals 2 pi. So the area is given by 1/2, 0 to 2 pi, r squared d theta. You can plug r in, evaluate this in your calculator, give you 18.8496. How do we solve this by hand? So you are going to choose a point. Let's choose theta equals 0 as our start point. We want to see at which angle will come back if you look at this point. So r equals 0. So we set 2 plus 2 sine theta equals 0. Give us sine theta equals 0. So theta equals 0, pi, and 2 pi. So this one gives us r equals 2, theta equals 0. 2 pi and 2 pi. So this is not right because when r equals 2, theta equals pi, it only gets here. So we have to pick this one and this one. That's why our angle is from 0 to 2 pi. Let's have a look at this second example. Find the area of the one petal of this function. If you plot it, it should look like this. Do the same thing, trace, hold it. So when theta equals 0, it's right here, going counterclockwise. And when theta equals, theta 1 equals 0, theta 2 equals 1.0472. It will come back for the first time to reach that point. So the area will be 1/2 theta 1 to theta 2 r squared d theta, which is approximately 1.0472. Same thing. Please check the answer here. Okay, how do we solve this by hand? So what do we do is if we choose this our start point, theta equals 0, if you look at that point, r equals 0, so 2 sine 3 theta equals 0. That means 3 theta equals 0, pi, and 2 pi. So theta equals 0, pi over 3, 2 pi over 3. We want to see when it first come back to 0, so we choose 0 and pi over 3. So the area 1/2, 0 pi over 3, r squared d theta. And it's the same as before. So by hand or by calculator, you have to be able to solve both ways. Let's have a look at the number 3 here. So if you look at number 3, find the area of the inner loop of this graph here. So this is the graph, the inner loop is here. If you use your calculator, theta equals 0 starts from here, counterclockwise. Okay, first when it reaches this spot, theta 1 equals 3.6652. And then it will keep going here, and then come back to the same spot. So theta 2, 5.759. So our area, 1/2 theta 1 to theta 2, r squared d theta, which is approximately 5435. And how do we solve this by hand? So in order to cover the whole region, we are going to choose this point as our start and end point. So we set r equals 0. If you look at this spot, r equals 0. So sine theta equals -1/2. So theta equals 7 pi over 6 and 11 pi over 6. So our area, 1/2, 7 pi over 6, 11 pi over 6, r squared d theta. So same answer. Let's have a look at the 2005 AP problems. If you look at this problem, given r and theta equals 0 to pi, dr d theta is given. So when theta equals 0, it starts from here, and when theta equals pi, it's here. So part A, find the area bounded by a region. So if we draw a ray, you see, so the ray covers the area. So that's exactly our formula. A equals 1/2, 0 to pi, r squared d theta. You can plug this into your calculator. This will give you 4.382. B, find the angle theta where x equals -2. So x equals r times cosine. So this gives us theta plus sine 2 theta times cosine theta equals -2. You can plug this into your calculator. Okay, you can plot y equals theta. You can treat theta as x in rectangular form times cosine of x, and then you plot y equals -2. You find the intersection. So in this case, theta equals 2.786. Part C. For this interval, dr over d theta is negative. What does this tell us about r? What does it tell us about the curve? Because dr over d theta is negative, that means as theta increases, r decreases. Because r is the distance from the point to the center, because r decreases, so the curve is getting closer to 0, 0. Part D. Find the value of theta on this interval in the first quadrant with greatest distance. So we are trying to maximize the distance. If you look at the distance from the point to the center, that's exactly our r here. So in order to find the maximum value, we need to take dr over dt, which is already given. 1 plus 2 cosine 2 theta, we set equal to 0. Find the critical points. You can use your calculator. So theta equals pi over 3. This is a critical point. In a closed interval, we have to make a chart. So theta, which is 0, pi over 3, and pi over 2, and r of theta, you can plug into your calculator. Give us 0, 1.913, 1.571. So our maximum value is at theta equals pi over 3, and our maximum distance is 1.913.